Hello everyone. In this video we are going to be going through 3 examples where I will differentiate algebraic functions using the quotient rule. So just like when we have the product of two functions, we have a rule in order to differentiate them. We have a rule for when we have a quotient in which we cannot simplify using algebra. And that rule is similar to the product rule in order here, g of x times f prime of x, but now we have a minus f of x times g prime of x. And we're going to divide that by g of x squared. In this case, f of x is going to refer to the numerator of our quotient, and g of x will refer to the denominator of our quotient. We're now going to move back into the kind of live portion of the video where I will do problems with you. I'm going to apologize now that it's a little bit dark since I had to record this video at night. So I hope you'll bear with me for this video, and I will do the other ones when it's a little bit brighter out. Hello everyone, we are back in my kids' playroom at the easel. The lighting is a little dark just because it's nighttime now, so I'm hoping that the video comes out okay, but we're just going to go with it right now. So in this problem we have the derivative of 2 over 2x to the 4th minus 5. Now, since this is a quotient that cannot be simplified using other algebraic methods, we're going to go ahead and use the quotient rule to differentiate. So what you might want to do on the side, what might be a good habit for you, is listing out all the pieces. So f of x is 2. That means its derivative is going to be 0. G of x is 2x to the 4th minus 5, which means its derivative is 8x cubed. Just have that kind of on the side. And then apply your quotient rule, because there is a lot of pieces to this rule. So it's g of x, 2x to the 4th minus 5, times the derivative of f, which is 0, minus f times the derivative of g over that denominator g squared. Now, it is not necessary to multiply this out unless you think that you want to do it. I don't really require you to. I don't see the point in it. A lot of times we may try to simplify if we see that there are pieces that can cancel after we kind of clean up this numerator. Otherwise, just leave it as is. It's probably the easiest way to avoid making any mistakes while you're doing the algebra stuff. Let's clean up this numerator. So I have 2x to the 4th minus 5 times 0. Well, that's just going to go away. Negative 2 times 8x cubed. That's going to give me a negative 16x cubed divided by 2x to the 4th minus 5 squared. In the second example, we see a little bit more of a complicated quotient here. We have 4x cubed minus 3x squared over 4x to the 5th minus 4. So this is definitely a problem where I really want to show you all the step-by-step, which may not be as easy to see if you're looking at it through a PowerPoint. So once again, just like I did in the first problem, I'm going to list out my f, my g, and their derivatives so that I have it ready and accessible. Once you get better at derivatives, you may not want to list it out, but it's just a nice way to always have that information right up at the front so that you're not making a little mistake thinking through the problem while you're actually doing the quotient rule. So f of x is 4x cubed minus 3x squared, which means its derivative is 12x squared minus 6x. G of x is equal to 4x to the 5th minus 4, which makes its derivative 20x to the 4th. Okay, once again, going through the quotient rule. The bottom, 4x to the 5th minus 4, times the derivative of the top, 12x squared minus 6x, minus the top, 4x cubed minus 3x squared, times the derivative of the bottom, 20x to the 4th, divided by the bottom squared. Again, it's not necessary to multiply this out unless you really want to, but I suggest you just leave it as is. We do have to clean up this numerator, so here I have a binomial times another binomial. We're going to have to multiply that out. So I have 48x to the 7th minus 24x to the 6th minus 48x squared plus 24x. That's just this binomial now. No like terms, it's going to stay as is. Now I need to distribute that 20x to the 4th into this second binomial here. So I'm just going to give myself some room because I know it's going to keep going. So I have here a negative 80x to the 7th plus 60x to the 6th, and that's divided by this 4x to the 5th minus 4 squared. Last step is to combine any like terms that I have. I have highest term looks like 48 and negative 80x to the 7th, which is going to give me a negative 32x to the 7th. Then we have the 6th, negative 24, and a positive 60. That gives me a positive 36x to the 6th. Then negative 48x squared plus 24x divided by 4x to the 5th minus 4 squared. I think that is everything. Quotient rule, we have 4x to the 4th minus 4x squared plus 5 over 2x to the 2/5 plus 3. So f of x is 4x to the 4th minus 4x squared plus 5. So f prime of x is 16x cubed minus 8x. G of x is 2x to the 2/5 plus 3. G prime of x is equal to 4/5 x to the negative 3/5. Okay, so we have g of x, 2x to the 2/5 plus 3 times the derivative of f, which is 16x cubed minus 8x, minus f, 4x to the 4th minus 4x squared plus 5 times g prime of x, which I'm just going to squeeze in down here, 4/5 x to the negative 3/5. Sorry, I had to squeeze that in a little bit. And then we have our denominator squared, 2x to the 2/5 plus 3 squared. Again, have to multiply all this stuff out. 16x to the 2/5 times, 2x to the 2/5 times 16x cubed. That's going to give me a 32x to the 17/5. So again, 3 is going to be 15/5, adding those exponents together, minus 16x to the 7/5 plus 48x cubed minus 24x. Okay, that's just this binomial times binomial. Minus, we have the 4/5 x to the negative 3/5 distributing into that trinomial here. So 4/5 times 4 is 16/5. X to the negative 3/5 times x to the 4th. 4 is 20/5. That gives me an x to the 17/5 because we have to subtract them. Again, this is 20 over 5. This is a negative 3 over 5. Plus, because again, the double negative here, 16/5 x raised to the, this is going to be 10 minus 3 is 7/5. And again, sorry, I have to kind of squeeze that last term because I wrote a little too big here. 5 times 4/5 is going to be a negative 4x to the negative 3/5. All divided by 2x to the 2/5 plus 3 squared. Last step is cleaning this thing up. So I'm going to start with my 17/5 since that's my higher power. 32 minus 16/5. 32/5 is going to be 160. 160 minus 16 is 144/5 x to the 17/5. Next highest power is going to be cubed. So I have only, it looks like, 48x cubed. Next highest power after that is the 7/5. So we have minus 16 and then 16/5 here. This is 80/5. 16, their difference is going to be a negative 54/5 x to the 7/5. Got that. Next highest power is going to be a minus 24x, and finishing off with that minus 4x to the negative 3/5. I think I got them all there. I'm going to double check that. Divided by 2x to the 2/5 plus 3 squared. Whew. And there you have it.